Okay, so we're going to go ahead and finish up that one page of notes that we were looking at yesterday in equivalent representations. Just give you a heads up if you haven't had the opportunity to look at next week's posting. Remember, on Monday, that's when we're going to talk about the homework for 1.9 and 1.10, vertical asymptotes and holes. And I've got the quiz scheduled for Wednesday. So our next quiz is coming up Wednesday of next week. Okay. We should be on track, or at least that's my goal right now, to go ahead and finish up this lesson by Tuesday. We'll go ahead and start the next one, transformations. We're actually only a few lessons out from the end of the unit, and then we can go ahead and start Unit 2, and we're on the long road to the AP exam. All right, so questions about what's coming up. All right. Was anybody in here interested in synthetic division? Okay, well, because I'm recording, I'm going to go ahead and say it anyway. If you take a look at the website, it's not letting me do that. So I did go ahead and find a website that does a really good job of walking you through it. You go ahead and click on here. Okay, I mean, it is A&M, but take what you can get. It does do a really good job of walking you through all the steps. So it makes it super easy to go ahead and figure out what synthetic division is. If this is something you're interested in, remember, I'm always going to be talking about long division. I will caution you, though, there is one restriction to synthetic division. In your binomial divisor, that leading coefficient on x has to be 1. So if it's anything besides 1, you have to change it in a specific way. Okay. Unfortunately, none of the problems on this website have any divisors like that. Okay, so if anybody is interested in taking a look at this, definitely come see me so I can walk you through the process and show you what to do. But that is available for you, okay, if you are interested. Okay, maybe tomorrow night, Saturday, friend rings you up, bring, hey, let's go out and hang out. No, well, I'm going to stay home and do synthetic division. A little quiet in here, but that's okay. All right. Okay, so with this, let me go ahead and set it up. I've got my divisor, x plus 1, and I want to divide it into my dividend, x squared, a negative x squared minus 1. So x plus 1. Now, you remember, I did mention yesterday, and that's kind of why I was drawn towards this problem. This is not in your notes. It's just kind of a recap from yesterday. You'll notice there's something missing in the dividend. What am I referring to? It goes from an x squared to what? Your constant. That's exactly right. Just C. If there is a term missing, you have to go ahead and place a 0 in with it. Okay, it's kind of like a placeholder more than anything else. So negative x squared, then we're going to have plus 0x, and then minus 1. Super important to do this because if you don't, then your like terms aren't going to line up. Okay, so you always want to take care of that. All right, so let's see if somebody can walk me through this problem. Who would like to go ahead and perform the long division for me? Okay, that means I get to use the Wheel of Destiny. I haven't seen the Wheel of Destiny in a while, so... All right, so let's see here. Let's go ahead and sort this out. Right now I'm only at 19, and we go up to 32. So... Okay. And I'll tell you what, I'll even go ahead and throw my hat in the ring. If it lands on 33, I'll take it. Okay. But the odds of that happening are pretty low. Watch it happen. Let me give this a good shuffle. Okay. So no volunteers. Here we go. Oh, unfortunately, Ella is not here. So that means we get to spin again. Everybody is hoping to see their number, but only one can come up. Oh, 29. Brian! Brian never fails. Look at the smile on Brian's face. He is so excited to come on up and show us this. Can hardly contain himself. Okay, so Brian, help us out here. I'm sorry? Up top? We need it to match up with a negative x squared. So let's think. You always start with the term that provides your degree. So here I'm going to start with the x, here the negative x squared. So x times what would give me this negative x squared? Negative x, there you go. Okay. So once you put that, what do we do with it? Yeah, you're right. So he distributed negative x across the binomial there. Okay, let me go ahead. So now once you've multiplied, okay, Brian, what do we do? Those are going to cancel because we what? It's the opposite of addition. We subtract. Okay. So see, when I subtract, that's actually a negative x squared plus x squared. That's why they cancel. So how many x's would I have here? Right here, right below. So I have a 0x minus a negative x. Okay, you're close. There's one thing you don't need in that. No, we need the x. Or was that your answer? Okay, so you said negative x, and I said there's only one thing we don't need with that. Just x. There you go. Yeah. Because the two negatives are going to make a positive. So we have 1x. And now before we start the process again, there's one more thing you got to do. There you go. We're going to drop down that minus 1. So x times what is x? Now x times x is x squared. Just 1. There you go. There you go. And now distribute 1 across that group again. So that would be x plus 1. Okay. And now we're going to subtract again. So x minus x cancels. Negative 1 minus 1. Negative 2. There you go. And that's it. That's all you do. Good job. Okay. Give him a round of applause. Good job. Good job. All right. Now remember, I talked yesterday because negative 2 is our what? That's our remainder. So I did show you how with the limit statement, we can actually show that it's going to basically go away. I'm not worried about doing that again. All we need to focus on is getting our slant asymptote. Remember, we're going to be looking for those in slope-intercept form. Okay. So any questions on that? Okay, good, good, good. Well, with this in mind, let's go on back to number 7. We don't have a whole lot to do. In fact, we should be finished up pretty quick. So yesterday we spent all of our time on number 7 looking at the long division. So we already know about the slant asymptote. Okay. So if there's a slant asymptote, there will not be a horizontal asymptote. Now, we still need to go ahead and find the vertical asymptote, but I went ahead and kind of extended this problem. I want to go ahead and find the whole, and this table is going to help me find the x and y intercepts. Okay, and you'll notice we already have one, and I'm going to talk about that. All right, so let's see. Vertical asymptotes, where do they come from? Numerator or denominator? They come from the denominator. Now, because I've already had a pair of groups cancel, all that's left in the denominator is x plus 1. Okay, so I'm going to set that equal to what? Remember, all these groups, we continually set them equal to 0. So where would my vertical asymptote be? X equals -1. Okay. All right. Now, we know there's a hole because we had a common factor cancel out. In fact, would everybody agree that the hole occurs at -6? Okay, so this is going to be a little more practice. Take a few seconds, find me the corresponding y value. So where's the location? -6 what? Okay, everybody about ready? Here's what you should be getting, -48/5. Okay, how many got that right? Good, good, good. Okay, so if you're not raising your hand, let's talk about it. Where did that come from? Okay. Hey, what's that? Plug it in. For every value of x that's left, I plugged in the -6. So the x up top, -6. -6 minus 2, there's a -8. Divided by, in the denominator, -6 plus 1, there's your -5. So there's your -48/5. Okay. Everything okay? Yeah, think what's going on is we're having a problem with vaping and stuff. That's crazy. All right. Okay. All I want to do on this problem now is find the x and the y intercepts. Now, I also wanted to do this because it's the first time that we've ever seen one that has multiple x-intercepts, and that's very possible. You can have several x-intercepts, but you'll only ever have just one y-intercept. Okay, so where do the x-intercepts come from? Okay, the numerator. So all that's left in the numerator is x and x minus 2, where once again I set those equal to 0. So if x equals 0, well, that's my one intercept. And you'll notice I've already got that one for the y-intercept. Okay, because the origin is both an x and a y-intercept. That's where the two axes touch each other. All right. And then if x minus 2 equals 0, where's the other x-intercept? Cameron. Where's my other x-intercept? Because we already took care of this x. It was 0. That gave me that one. So what's the only thing left in the numerator? Two. Because if x minus 2 equals 0, x would equal 2. Okay. All right. Good, good, good. All right. Let's take a look at number 8. Now, number 8, it is partially factored. The numerator is factored, but the denominator is not. So x squared minus 2x plus 1, who can help me out with that? Two numbers will multiply to 1, but add to -2. Keegan? 1 and -1? Very close. -1, -1. So let's go ahead and write it as x minus 1 squared. Or if you want to go ahead and make it x minus 1 times x minus 1, you're fine. Now, I want to give you a few seconds to try this problem. It's actually been pretty tricky for students throughout the day. All right, now, for a problem like this, I can't emphasize enough, it's always a good idea, read through your answer choices before you go ahead and make your selection. All right, so the graph of d of x has one horizontal asymptote, one hole, and one vertical asymptote. Has one horizontal asymptote and two vertical asymptotes. Has one slant asymptote, one hole, and one vertical asymptote. Or one slant asymptote, no holes, and one vertical asymptote. So what is happening for function D? And then we'll do a little poll. We'll kind of see how the class is responding. Excuse me. Okay, everybody think they made their selection? Okay, so let's see what the class thinks. How many believe it's A? I like how people are looking around the room to kind of see what other people are doing. Okay, so I don't see any hands on A. Okay, what about B? Oh, so far we're pretty unanimous. What about C? Oh, so now I'm starting to see some hands go up. Okay, what about D? Okay, so it looks like we're almost split between C and D. How many people are not going to vote? Thank you, Lee. Okay, it is D. Okay, now let's talk about it. Do you notice anything between the numerator and denominator? Okay, but they're not the same, but we do have a common factor. Okay, so wait a minute. I thought that if a common group canceled, that automatically guaranteed a whole. That's exactly right. Remember, this is the one exception. If you have a pair of groups that cancel, but one of those canceled groups is still in the denominator, it's a vertical asymptote. It's not a whole. Okay. Now, if you cancel out some group factors, but that canceled group factor is still in the numerator, then it's a whole. Okay. Then it would be a whole. There you go. And if you remember that one particular fact, you didn't even have to look at slant asymptote or vertical asymptote because it was the only one that said there was no whole. Okay. All right. Good. Here is our last question for the day. All right, example 9. So it says sketch a picture of the rational function. Now, answers are going to vary. We're going to go ahead and talk about this, and then I'll give you the opportunity to go ahead and sketch one, and we'll see how close it resembles the one I drew. But let's look at our first two limit statements here. It says the limit, okay, as x approaches both positive infinity and negative infinity. Okay, so we're talking about our ends here, our left and our right side behavior. Now, the answer is negative and positive infinity. Because we're talking about the ends, what are we referring to? Would this be describing a horizontal asymptote, or is it describing a slant asymptote? Okay, why couldn't it be describing a horizontal? Not the fact that they're opposite. Let's say we have a horizontal asymptote. Somebody give me a number. 3. Let's say that the horizontal asymptote is y equals 3. Okay. Well, if we were actually talking about a horizontal asymptote here, then as we go infinitely to the left and right, then we should be approaching the asymptote itself. Okay. But because on the ends we're getting extremely large or extremely small, and we know we're talking about a rational function, we have to be talking about a slant asymptote. So is everybody okay with that? All right. So that means one of two things. Either the asymptote is going to have a positive slope, it's going to rise to the right, or it's going to have a negative slope, it's going to drop to the right. Which one do we think it is? Okay. Will it rise to the right, or will it drop to the right based on what we see here? Okay. So what do you think? It's going to rise to the right? Very close. It's going to drop. Okay. And how do we know that? Well, as it goes to infinity, as x gets larger and larger on the right, what's it telling me it's doing? The y values are what? The y values are getting smaller and smaller. But this one here, as we approach negative infinity, what are the y values doing? they're getting larger and larger. So I know it has to be a slant asymptote, and I know it has to drop to the right. Okay, well, let's take a look at the other one. Besides a slant asymptote, we're told that the limit, as x approaches -1 from the left and the right, is a negative infinity. Okay, so if in a limit statement you're approaching a specific number, but the answer is an infinity, is that describing a hole or a vertical asymptote? That's a vertical asymptote. Okay, so you know you have a slant asymptote, and you know you have a vertical asymptote. So go ahead and sketch me a picture of what could give me these particular rules. Just one graph. Now, because you have a vertical asymptote, there's going to be two branches, two parts to it. The number of parts to a rational function is always going to be one more than the number of vertical asymptotes that you have. And remember, odds are yours is not going to look like mine, because while it drops to the right, maybe you're going to make it extremely steep. Maybe you'll go ahead and make it almost horizontal. And then you also have to decide where is it going to cross the y-axis. Okay, so you have a lot of freedom in that slant asymptote. Vertical asymptote, everybody should have it in the exact same place. Okay, let me go ahead and erase all this stuff. Get ready for the next class while y'all are doing that. Okay. You know what? I'll erase that too. Okay. So we need a slant asymptote, and we need a vertical asymptote. Okay. All right. Like I said, sketches are going to vary. Here's what I came up with. Okay. I just went ahead and put my slant asymptote through the origin. Okay. Now you'll notice for the vertical asymptote, both on the left and the right, the graphs want to curve down towards that vertical asymptote. That's why I went ahead and put both of these below the slant asymptote. Again, it didn't say anything about x or y intercepts. It didn't say anything about holes. So this sketch satisfies those four conditions. Okay. All right. How are we doing? Yes. Okay. So let me go ahead and reset this for the next class. And we are done for today. Okay, don't forget on Monday we're going to be talking about the 1.9 homework, 1.9, 1.10.